Okay, so today we're going to look at the second conic section. So we did parabolas. It's when you slice a cone on a diagonal and you slice it through the bottom of the cone. An ellipse is another shape you can get, and the way you get that one is if you take a cone and you slice it, but you don't come out through the bottom. You slice it right through the side of the cone on an angle, not straight across. Because if you were to slice it straight across, what shape would that give you? That would give you a circle. So you got to slice it on a little bit of an angle, and then the cross section would be an ellipse. So pretty much every definition of a conic section starts out this way. It's a collection of points in the plane that satisfy something. Again, because it's in the plane, that means it's a flat, it's a two-dimensional shape. And it's the collection of points in the plane. And we're looking at the sum of two distances. Okay, it says the sum of whose distances from two fixed points is a constant. So that's kind of like a circle, almost. Okay, if I was going to write the definition of a circle, I would say a circle is a collection of points in the plane that are equidistant from one fixed point. Okay, from one fixed point. An ellipse, if you add the distances to two fixed points, it comes out the same. Okay, so we'll take a look at a picture, and I think it'll make that a little easier to understand. So here's two fixed points, okay? Point B and point C. Those 2 points aren't going to move. Point E is a point on the ellipse. So what I'm saying is if I add the distance from B to E and the distance from C to E together, I will always get the same number. In this particular ellipse, it happens to be about 17.3. That can be different. But watch as I move it. Notice the length of each segment is changing. At this point, segment EC is pretty much the shortest it would ever be. And segment BC is the longest. But even though those two lengths are changing, when you add them together, adding those two numbers up gives you 17.3. Okay? No matter where you move it. And the way that I'm kind of tracing that, you could draw an ellipse exactly the way I'm doing it right here. If you had like a bulletin board or something, okay? And you put two push pins in it at points B and C, and basically take like a loop of string and put it around those 2 points, and then pull it tight and drag a pencil around it. That's how you can draw an ellipse. Exactly like that. You just need two fixed points. And what eventually happens is these two fixed points move closer and closer to each other. What shape do you think I would eventually get?
Circle.
I'd get a circle. Okay? If points B and C eventually become the same point, then you have a circle. Okay? But if you have two separate points like that, that's an ellipse. Okay, so any questions on the definition of an ellipse? All right. So you're adding the distances to two fixed points, and it always comes out the same. Does anyone have a guess what those two fixed points are called? It's a term that we saw yesterday. Yeah, we have a focus on the left and a focus on the right. So the plural of those is the foci. So an ellipse has two. It has two foci. And with a parabola, there's basically 4 different ways you can draw it. It can open up, down, left, or right. With an ellipse, there's really only 2. Either your ellipse is more of a horizontal ellipse, or it's drawn more as a vertical ellipse. Okay, those are the only 2 ways you can draw it. If you draw it in the horizontal direction, okay, the way I have here, I've got F1 and F2. Those are the 2 foci. The very edges of the ellipse, okay, going the long way. This and this. I labeled V1 and V2. Does anyone have a guess what those V1 and V2 stand for?
Vertex 1 and vertex 2.
Yeah, they're the vertices. Just like on a parabola, the vertex is the point that's like lowest or highest or whatever it is. Well, these are the points that are farthest right and farthest left. If I drew my ellipse this way, it would be the highest and lowest point. Right? And all I'm showing right here is exactly what I just described in the definition. If you take the distance from any point on the ellipse to the first focus, and that same point to the second focus, if you add those two distances together, it always comes out the same. I think in my example, it was like 17.3 or something like that. Okay, and I've also labeled two other things here. Okay, what's called a major axis and a minor axis. So if you draw a line through the foci, that is the major axis of an ellipse. Basically, the major axis goes the long way in an ellipse. Okay, so the line containing the foci, that's the major axis. And then if you were to draw a line segment, just like that, between F1 and F2, and you find the midpoint of that segment in green, that would give you the center of the ellipse. Now you could also say, well, what if you drew a line segment from V1 to V2 and then found the center of that? It's the same thing. Okay. Okay, so the midpoint of the segment that joins the two foci, that's the center. If you draw a line through the center and perpendicular to the major axis, that's the minor axis. If I just go back up a little bit, there's your center. Draw a line right through the center, perpendicular to the major axis. That's your minor axis. Okay. Simple way to remember, the minor axis goes the short way. Major axis goes the long way. Okay, and the last thing I labeled in the picture were the vertices. And to describe it accurately, rather than saying like it's the point furthest left and right, you could say it's where the major axis crosses the ellipse. So if I just scroll up a little bit, V1 and V2, it's where the major axis crosses the ellipse. So thinking about some of the terms we studied yesterday, what terms are new here? Terms that didn't really apply to parabolas. Yep, Luke?
Major and minor axes.
Yep, we didn't have major and minor axes when we talked about parabolas. That didn't exist. What else? Yep.
Like a center point.
Yeah, there was really no such thing as a center of a parabola. No, we didn't have that. But with an ellipse, we do. How about anything here that's the same? What's a term that we used yesterday, we're using again today? Yep. Vertices. So the only difference is we have two. Yesterday we only had one, but we're still talking about vertices. And
Focus.
yeah, the focus. And it's the same as the vertices. The only difference is we're talking about two of them rather than one. Directrix is another term that is not mentioned at all here. Okay, so we won't be using that again. In major and minor axis, that's something that's just special to an ellipse. You won't see that on any other shape either. But vertices, foci, center, those ones come up on pretty much all the shapes. All right, so this time I said there's really two cases. Unlike a parabola, you had four. Okay, we're going to look at the first case. Simplest one is where it's not translated. The center is at the origin. Okay, so we have the center at the origin. The foci are going to be given by those two coordinates, negative c0 and positive c0. The major axis is going to be horizontal, which means it's going to look something like this. And the vertices are going to be given by negative a0 and positive a comma 0. So just like when we had a parabola, we had to find h, k, and a. Well, we've got to find different letters here too. And if you can find the letters, all you have to do is plug them into the formula. And it'll tell you where the foci and everything is. So that's the equation for an ellipse. That meets all these conditions. A couple important things. Which variable here is squared? The x and the y. They're both squared. With a parabola, we're both variables squared. Just one of them. That's what makes something a parabola. One variable squared, one variable isn't. Here, both variables are squared. That makes it an ellipse. The other thing is that it's equal to 1. Anytime you write the equation of an ellipse, we always get it equal to 1. It's not something we did with a parabola. Okay, and then a couple conditions about A and B. First of all, A and B are always positive. And second, A is always bigger than B. So basically the trick here is if you want your major axis to go horizontal, you put the bigger number under the letter that goes horizontal. X is the horizontal. If I were to switch A and B, okay, which we'll do in a little bit, then the bigger number would be under Y. If you put the bigger number under Y, that causes the major axis to go up and down. Okay, so wherever you put the bigger denominator, that controls which way your ellipse is going to go. And A is always the biggest number. The other thing is this relationship between A, B, and C. Kind of looks like the Pythagorean theorem, but it's definitely not. Okay, it's c squared equals a squared minus b squared. So that's important because if you know two of the letters, you can find the third one. Okay? And that's usually the kind of problem they give you. They'll give you 2 out of 3 letters, and you have to plug them in and find the third one. Sometimes that's helpful, not always. To graph an ellipse, I think your book mentions that. But the problem with that is you could have an ellipse like this. We're not doing one that's been shifted yet, but this ellipse doesn't cross any axes. So sometimes you'll have intercepts, sometimes you won't. Okay? Depends. All right. So now I think probably the most important thing is what are A, B, and C? Okay? How do you know what they are? So A is the distance from the center to the vertex. B is the distance from the center to where the minor axis crosses the ellipse. And C is the distance from the center to the focus. Okay, so off to the side, I just summarized what I wrote on the board in a shorter way, just so I can remember it. So A is the distance from the center to the vertex. B is the distance from the center to the minor axis. And C is the distance from the center to the foci. And when we study our last section tomorrow, hyperbolas, A and C are going to be exactly the same thing. B, not so much, but A and C will have I'll write that exact same thing on the board tomorrow. All right, so any questions about what A, B, or C are? So again, you could summarize it a lot shorter than I wrote it, but if you want it fully described, that's how you describe it. Okay. So, just like we did yesterday, first thing I have to do is if I want an equation, I have to find all the letters that I need to plug in. So they gave me the center, they gave me the focus, they gave me the vertex. They gave me everything I need. So, does anybody see one of these three letters we have enough information to figure out?
A.
Sure. A is the distance from the center to the vertex. If you graph the center and you graph the vertex, how far apart would they be? 4 units. Remember, whatever you write for A and B, they always have to be positive. Don't ever write negative numbers for A and B.
You can also do C.
Yep, we can find C because that's the center to the focus. How far apart are those 2 points? 3. Now, the problem is we need B. Because if you're going to write the equation of an ellipse, you don't even really need C. You need the A and the B. But the only way to get the B is to use what you know to find it. So C squared equals A squared minus B squared. So off to the side, I'm just going to put find B. And I'll fill in what we know. So indirectly, you do need C to get B. But when we write our final answer, it won't be part of the final answer. Yep. Yeah, let's go through it and see. So we get 9 equals 16 minus B squared. Subtract 16, we get negative 7 equals negative B squared. You get a negative on each side, so we can cancel it. And B is the square root of 7. Yep. Okay, so there's all the information you need. Now fill it into the formula. Okay. Any questions on how we found that? That's the hard part. Okay, now the easy part. X squared over A squared. So X squared over 16 plus Y squared over B squared. Y squared over, and B is the square root of 7. So what's B squared? 7. And the equation of an ellipse is always equal to what number? 1. There's your equation. And notice here the bigger number is under the X. That means if you were to sketch this, it would go the X direction, the horizontal. If you switch the 16 and the 7, then it would look more like this. The bigger number would be under Y, and the major axis would go in the Y direction. Okay. Any questions on that one? All right. So this one, let's see, they're giving us the equation. They want us to discuss it. Okay. So discussing it means you got to write down the center. You should write down the coordinates for the vertices, the foci. Tell me what direction the major axis goes. That's pretty much everything. Okay, but to do all of that, we need A, B, and C. So what is A here? Yeah? 5. Remember, A is always the bigger number, but this is A squared. So A is 5. How about B? B is 3. It's the square root of the smaller number. And now C, if you want to write the coordinates for the focus, you need to know C. So what's the connection between A, B, and C? What's the formula?
C squared is A minus B squared, right?
A squared minus B squared. Okay, so take a second, do that out, and write down what C is. Okay, and then we'll come back in 1 second and take a look at it. Okay, so when we went through that, what did you get for C? 4? Let's double check. 25. Oops. C squared equals A squared, which is 25, minus 9. So C squared equals 16. And then you take the square root, and you get 4. Now, you don't have to write positive or negative 4, okay, because C is a distance. Distances can't be negative. Okay. All right, so now let's write down everything. Okay, just like we did yesterday, we haven't done any shifting yet. So where is the center right now? 0, 0. It's 0, 0. Let's do the vertices. Actually, you know what? Let's do the foci next. It doesn't really matter. You have to write them all anyway. So foci. Let's go back and look at our chart. Foci, negative C0, and then positive C0. All right. So where are my foci?
Negative 4, 0, and 4, 0.
Yep. Okay, let's do the vertices next. So the vertices are negative A0 and positive A0. So where are my vertices? Negative 5, 0, and 5, 0. And let's just say which way the major axis goes. Which way is the major axis here? Horizontal or vertical? Yeah, it's horizontal because the bigger number is under x, so the major axis goes in the x direction. Okay, and let's graph that one. We don't really graph a lot of ellipses, but just to practice graphing one of them. So the center is not actually a point on the ellipse. It'll be in the middle of it. The foci will not be on the ellipse. They'll be in the middle of it. So we'll call that F1, F2. But the vertices will be on the ellipse. It's a negative 5, 0, and 5, 0. And now, does anybody remember how we can figure out how wide the parabola is? The distance from on the minor axis? What letter tells me that?
Well, we know that it's going to be on the 0 on the x-axis, right? So.
Right, but I don't know how wide to make it. That's what I'm not sure about. So what letter tells me the distance from the center to the minor axis?
B.
B. The distance from the center to the minor axis is 3 units. 3 and 3. So, it's kind of hard to sketch it. Perfect, but yeah, it's close enough. So there's your ellipse. A lot of people forget about that distance from the center to the minor axis. That's B. If you wanted to sketch it, you'd need to use that. Okay, so any questions on those 4 things? All right. Okay, let's try the equation now where the major axis is vertical. So really the only thing that happens in the equation is A and B switch places. The center is still at the origin, but notice here your foci and your vertices are going to line up vertically now. So if you look at this problem, they were all in a horizontal line. V1, F1, F2, V2. Now they're going to be more like this. Vertical. So the foci are C units above and below the center. The vertices are A units above and below the center. And if you think of it the way that I just said it, that's going to help when we shift it. The vertices are always A units away from the center. wherever the center is, even though in this case it's still going to be 0, 0. Just like before, A is bigger than B, and B is greater than 0, so A and B are both positive, and A is always the bigger number. And C squared still equals A squared minus B squared. Okay, so when they ask us to, what are they going to do, right? Discuss an equation. What's the first thing you usually want to do when you discuss an equation? Find A, B, and C. Okay, if you look at the problem that I'm going to give you, is that equation written the way that it should be? No. What's wrong with it? Well, the x's and y's are both squared, so that's okay. That's still an ellipse. But something is very wrong with that equation to look like this one.
Doesn't equal 1.
It doesn't equal 1. So that's the first step. If you want to figure out A, B, and C, you've got to get it equal to 1. And then whatever your denominators are, just take the square root of them, and that's A and B. So how would you get that equal to 1? Yeah, divide everything by 9. And now it's going to look exactly like it should. So it's 1 on the right. When you do 9 divided by 9, it cancels out. And what are you left with in the bottom? What, Demi?
1.
Yeah, you're left with 1. If you want to put something there, you could just put a 1. And then y squared divided by 9. Okay, so what is A here?
9.
Careful, that's A squared.
Okay,
3. Remember, A is always the square root of the bigger number, wherever the bigger number is. B is the square root of the smaller number. In this case, the square root of 1 is 1. And then C, well, just use your formula. C squared equals A squared minus B squared. 9 minus 1. So what's C? Square root of 8. Those are the 3 numbers you need to know to describe everything about the ellipse. Okay, let's start with the center. Where's the center? 0, 0. You'll know when it's not 0, 0. Let's do the vertices. The vertices are A units away from the center. And in this case, since the bigger number is under y, they are above and below, not left and right, above and below. So what would be a coordinate 3 units above the center?
0, -3. Or 0, 3.
Yep.
0, -3.
And then 3 units below would be 0, -3. The foci are C units away from the center. And again, this time it's above and below. So what would be the coordinate for C units above the center? 0 square root of 8. And how about C units below the center?
0, negatives.
Yep. And the last thing, probably just say what direction the major axis goes. Okay. How does the major axis run in this problem? It's vertical, because the bigger number is under y. Okay. So that's everything you have to describe when you discuss an ellipse.
Why is A 3?
A is 3 because it's always the square root of the bigger number. Yep. And B is always the square root of that number. But it's the same, because the square root of 1 is 1. Okay, other questions on that one? All right. Okay, let's see, find an equation of that ellipse. What am I missing here that would be helpful if I knew it? Pretty much it's used to find A, B, and C, but we don't have it. The center. Right? If you want to find A, B, and C, A, B, and C is the distance from the center to something. We don't have the center. But I said earlier that the center is basically the midpoint. Okay? So if you drew your vertices, call that V1 and V2, the center is the midpoint of the segment between V1 and V2. So where would the center be here? The center is 0, 0. And there's actually something else they didn't write in this problem, but we know it has to be true. What's one other piece of information that they didn't give us? They did on the vertices, but they didn't on the focus. The what? Plus or minus, right? The focus, there has to be two of them, and they're symmetrical. So really, you could put a plus or minus 2. All right, so let's start with A. What's the distance? Well, you tell me. How do you find A? It's the distance from what to what? Center to the vertex, which is 3. Okay. How do you find C? Well, C we can find directly, because they gave us the information we need. Center to the focus. What's the distance from the center to the focus? 2. B is what we don't know this time. Okay. And the equation, I heard some people just saying it. Use that equation to find B. Okay, so we can get 4 equals 9 minus B squared. So if we solve that out, what will you get for B? Yeah, you're going to get the square root of 5. That's what you need to write the equation. Now, we have to figure out, because they didn't tell us, does the major axis go vertical or does it go horizontal? The major axis is going to go right through all the important points. So in this case, do the important points line up vertical or do they line up horizontal? Yeah, they're going to line up vertical. I didn't finish graphing all of them, but here's the focus. And here's the other focus. Everything's going to line up vertical. So when you write your equation, you can pretty much start with this. If I want this to go vertical, where does the bigger number have to go? Under x or y? Has to go under y. So that means we're going to put a squared under y. So what's a squared? 9. And what's going to go under x squared? B squared, which would be 5. There's your ellipse. Any questions on that one? No? All right. So really, I think that's those are the hardest. If you understand that, shifting it left, right, up, and down is pretty easy. That's probably the hardest stuff to understand. So really quick, we're not going to spend much time on it, but a circle is basically a special case of an ellipse. Okay? A circle is basically where the two numbers in the bottom are the same. And that number in the bottom, if you multiplied everything by a squared and moved it to the other side, that's how they write the equation of a circle. That number is your radius. Okay, so that's all that a circle is. It's take the equation for an ellipse and make both numbers in the bottom of the fraction the same. And for some reason, they usually move it to the other side. They don't set it equal to 1. Okay, so as far as what I want you to understand about circles, that's it. I just want you to understand it's a special case of an ellipse. When I give you problems about ellipses on the test, none of them will be a special case. They will all be ellipses. They won't be circles. Okay, so any question on how an ellipse relates to a circle? All right, so the last thing we're going to look at is what happens when you shift the ellipse. And we're going to use the exact same letters we used when we shifted a parabola, HK. This time, though, there's only 2 cases to look at. So if you're going to put down a formula on your reference sheet, these are the 2 formulas that I would put down. There's one case where the major axis is horizontal, and that's where you put A, the bigger number under X. And then there's a case where the major axis is vertical, and that's where you put the bigger number under Y. So the only thing that's different is that. That minus H and minus K, that's what will shift your parabola up, down, left, and right. H will control movement left and right. K will control up and down. Another thing, H is always with X. K is always with Y. Let's see, what else? A is still the biggest number, and A and B are always positive. That's the same. C squared still equals A squared minus B squared. That's the same. And everything else we wrote earlier is the same. A is still the distance from the center to the vertex. C is the center of the focus. That's all the same. And if you want to look these up on your in your packet, it's on page 394. So when we want to write the equation of an ellipse that could be shifted, how many letters do you need to find?
7. Including X and Y.
Well, X and Y, those will always be in the final answer. You won't have to fill in for those.
5.
Yeah, but there's really 5 letters. You have to find the A, B, and C, just like we did before, and the HK. That's the center point. Okay. So I've already kind of written out a template here. Sometimes I like to do that right away on the problem so I know what I'm looking for. Okay, so that's always the template you want to set up for an ellipse. HK, ABC. Okay. Out of those 5 letters, is there anything that I know right away? I don't have to do any calculations at all. Yeah, what's H?
2.
2. That's H. Anything else? K. What's K? HK. Now, A is the distance from the center to the vertex. Do I know the center? Yep. Do I know the vertex? Then I can find out how far apart they are. Okay. These 2 numbers are the same, so you don't really have to look at that. They're 3 units apart. 2 and 5, 3 units. So A is 3. What other letter can I find directly without any kind of fancy formula? C. C is the distance from the center to the focus. Again, the negative 3's are the same, so just look at the x coordinates. 1. But to write the equation of ellipse, you have to have b. So how do we get b? Yep, c squared equals a squared minus b squared. So what is b going to be? It's going to be the square root of 8. So now you've got everything you need, but there's still one more thing we have to figure out. What's the last thing I have to figure out? Which way the major axis goes. Should I plug into the horizontal or should I plug into the vertical? Okay. And what I usually do is just graph your vertices and foci and see how they line up. Or if you can tell just by looking at it, that's good too. Okay. The foci, right 3, down 3. So just kind of a quick sketch. Vertex, right 5, down 3. I don't even have to keep graphing things. How are these points lined up? They're horizontal. That means you're using that one. Put the bigger number under x. All right, so let's start out x minus h squared. So we've got x minus h squared. And I said put the bigger number under x. So these are the two numbers we're going to be in our denominators. Which one is bigger? Which one? So you said b is bigger?
Yes.
Um,
Well, because then you have to square it anyway, so just.
well, if you took the square root of 8, that'd be about 2 point something. So a is always bigger than b. Always. Every single problem. A is always the bigger number. So what goes in my denominator?
3.
Careful, not a in the denominator. A squared, which is 9. Plus, now the other fraction is y minus k squared. What's going to happen when I write y minus k? It's going to be y minus minus 3. So I'm going to fix that right now. So y plus 3. And what's going to be my denominator there? 8. And the equation of an ellipse is always equal to? 1. Yep, it's equal to 1. And there's your ellipse. Sure. Okay, so any questions on that one? That's the hardest type of ellipse problem you could have, because you have to find all 5 letters. All right. Does anybody want to try one more like that I give you on your own? Let me pick one from homework. So let's try probably 39 to 45. Those are going to be the hardest ones. All right, let's try 45. So this one's kind of like what we just did, but it's in reverse. I'm going to give you the equation. I want you to tell me the foci, the center, all that stuff. So we've got x plus 5 squared plus 4 times y minus 4 squared equals 16. Okay. And just to kind of start you off, what's wrong with that? It's not equal to 1. We did one like that. So what do you have to do? And how do you do that? Divide everything by 16. 16, 16, and 16. So now, you've got it in the right format. 4 goes into 16 how many times?
4.
4? And 16 divided by 16 is 1. Okay, so see if you can figure out how to discuss that. Okay, I want to know the vertices, foci, center. Center is probably the fastest one to find. And then tell me the direction of the major axis. Okay, so take a couple minutes and see if you can figure out those 4 things. All right, so before you can really start to figure out any of those 4 things, what should you do first? Well, first thing was to write the equation the way we did, but now that we've done that, what would you do? Any thoughts? John, what did you try?
Getting the center.
Even before that, what do we need to find the center?
You need to know what equation it's for the horizontal major axis.
Okay, we do know that it's horizontal. But to find the center, the vertices, and the foci, what do we need to know?
How exactly do you know it's horizontal?
Because the bigger number is under x.
Oh.
Yep. Yeah, you need HKABC. That's always the first, well, or second step. Okay, let's start with H and K. If you look back at the formula, H is always with x. It's the number after the minus sign. K is always with y, and it's after the minus sign. So, what is H here? -5. Yep. And what about K? 4. That's your center. -5, 4. It's important we get that right because everything else we do is going to be based off that coordinate. How about, let's see, A. What's A here? 4. B? 2. And then C would be C squared equals A squared minus B squared. Square root of 12. All right. I'm just going to move that. So the vertices are A units away from the center. Are they going to be above and below or to the left and to the right? They're going to be horizontal. So A is 4. What would be the coordinate that is 4 units to the left of the center? -9, 4. What would be the coordinate that is 4 units to the right of the center? -1, 4. And now, what number there helps me to figure out the foci? C. Okay, the foci are going to be C units away from the center, to the left and to the right. So there's not really a nice way to write this one. It's just going to be, I would say -5, and if you're going to shift left, square root of 12 units, and then you're going to shift right, square root of 12 units. Okay, so that comes out kind of messy. But that's where your foci would be. Square root of 12 units to the left and to the right of -5. The vertices came out more typical. I think on the test, that's more how the coordinates are going to come out. They're not going to come out as messy. Okay. So any questions on that? All right, so again, kind of thing, it does take a little practice. It's not super hard, but there's a lot of things to remember. It's a lot. There's a lot going on. But it's not really difficult calculations. All right, so on the homework, that was number 45 that we just did. So it's 3 through 17, odd. 13 through 17, odd, sorry. 21. 27 through 31, that is also odd. And 39 to 43. So all odds. Okay, so we'll take a look at that tomorrow, and then we'll finish conic sections tomorrow with hyperbolas.